Okay, so the last thing we need to do with this is to create a summary of our results and ultimately find kind of the payback years of the installation of these turbines. So I created a summary tab. I've got these things. I'll go through them one by one. Remember, at this point, I have basically the power output of a single turbine. You'll have to find the other two. I also have the electricity costs and needs of the campus. Okay, so coming back here, okay, we'll go ahead and put in some of the data that I've already gotten. So, how much energy, how much electricity do I need to run the campus? So come over here and I will select that. That's the number of kilowatt hours that I've got. Okay. And then how much cost is that? Well, I'll come over and grab the cost now, which is about $250,000. We did that in part one. Okay. Now you go and you can see I'm doing this for Vestas. You have two other columns, excuse me, that you'll include on this. But for the Vestas, I will come over here and I will grab um, the amount of a single turbine. That's what we calculated over here. Okay, so I'll go equal, and then I'll come grab this one over here. That's how much power, energy a single turbine can produce. Okay, now, how much does it cost? Okay, over in here, you can see that I've got both installation and operation and maintenance costs. So it's $2.8 million per turbine to install it, and 50,000 uh, per year per turbine in maintenance and operation of uh, this guy here. So I'll go back here and I'll plug those values in. So 2.8 million and then 50,000 were the operation and maintenance costs. Now, how many turbines do I need? So what I'm going to do here is I'm going to take my total electricity and I'm going to divide that by the number of turbines or the amount of energy a single turbine can create. And you see I need about 2.5 turbines, but of course I don't want 2.5 turbines. I need a solid number. So I'm going to round this up to 3. Okay, and I can actually use a um, function called round up, okay, to the nearest whole number, which will force this to go up to 3. And of course, this is going to produce excess energy. Okay, so the total amount of energy production then is just going to be number of turbines times the amount that each turbine can put out. So again, I need, what is that, 3.5 million kilowatt hours, and I'm able to produce with these 3 turbines a little over 4. So the excess energy that I produce is going to be what I produce minus the needs that I've got right there. So I'm producing an extra 600,000 kilowatt hours. Now the question becomes, I get to sell that back. What do I sell back at? In the problem statement, you see right up here, you can sell back at 90% of what we bought it at. So what I'll do is I'll say, okay, equal 0.9, which is 90%, times, and I'll come over to my electricity data, and I've got my price per kilowatt hour. So I take my kilowatt hours, I'm sorry, I take 90% times that. So I get to sell it back at, instead of 7 point whatever cents, I get to sell it back at 6.6 cents per kilowatt hour. Okay. And then I'm going to take that value and I'm going to multiply it times the total amount of energy, the excess energy. So basically, I get to sell back $41,000 worth of energy. Okay. Now, remember, my annual operation and maintenance is 50,000 per turbine. So I'm going to take 3 times that 50,000. Okay. So that's 150,000 that I've got. So what is my total profit? What am I getting back? What am I saving by this installation, right? So I no longer have to pay the $250,000 to the energy. In fact, I get an extra $41,000 back from the energy. So that's close to $300,000 that I'm getting back. However, there are costs associated which is that total operation and maintenance. That is going to be B12, the one right above, and I'll hit enter. So let me just, well, you can't really see it, but again, that's the, um, I'm saving the 250,000. I'm actually profiting another 40,000, but then it's costing me the 150. So I basically overall am going to make $150,000. So now the question is, how many years is it going to take to pay back that installation cost? Well, what is the installation cost? Well, that's going to be 3 turbines times $2.8 million. So how long is it going to take me to pay back the $8.4 million? How many years, right? At basically $150,000 each year. So I'm going to take that total installation cost and I'm going to divide that by how much money I'm getting back each year. And you can see this takes 56 years to pay back. Okay, given the life of a turbine's 25 to 30, this is probably not a super good investment. However, you've got 2 other turbines that you'll go through and do this entire thing for, and you'll come up with the same payback year. This is the answer that you want to find for um, each turbine, and that basically is going to define the feasibility of putting these windmills here. You can see here the Vestas maybe is not the best one to put in. You'll go through and you'll do the other two, figure back payback years for those, and see if they're going to be worth it. And that will conclude the assignment, the final for the wind project in Excel.